There's something really weird about artificial intelligence. It kind of lives in this world of bizarre paradoxes. One minute, it's pulling off these superhuman feats that just blow our minds, and the next, it's completely failing at tasks so simple a toddler could figure them out. Let's dig into that contradiction, shall we?
So, on one hand, you've got an AI that can master the game of Go, a game with more possible moves than there are atoms in the universe. It's an absolute genius. But then, on the other hand, that same kind of AI can be completely stumped by a simple new puzzle it's never seen before. Suddenly it's clueless. So what is going on here? How can something be a grandmaster and a total dunce at the exact same time?
Well, the answer comes down to what we call the skill paradox, and it exists for a really simple reason. We've been confusing two totally different things, skill and intelligence. They are not the same thing, not even close. And understanding that difference, well, it changes everything. Okay, check this out. This hierarchy is a super useful way to picture it. Think of it like a pyramid. Down at the very bottom, you have these really specific, narrow skills, like playing one single game of Go. A level up from that, you have broader abilities, like being good at board games in general. And then, at the very top, the peak of the pyramid is general intelligence. That's the engine, the core thing that lets you acquire all those other skills to begin with. Right now, AI is incredible at that bottom layer, but it really starts to struggle as you move up.
For decades, the entire field of AI has basically been guided by this famous definition from one of its pioneers, Marvin Minsky. And look, it's a great definition, but notice where the focus is. It's all about performing tasks. It's about the output, the skill. And that mindset, well, it sent the whole field down a path of just trying to build systems that could do smart things. And this, right here, is where we kind of took a wrong turn. See, by focusing only on how well a system could perform a task, we started measuring our progress in a really misleading way. We got so fixated on the destination, that superhuman skill, that we totally forgot to look at how the AI actually got there.
It turns out you can pretty much buy superhuman skill. Here's the recipe. First, you pick a super narrow, predictable task. Next, you just flood the AI with an insane amount of training data. I'm talking about one system that was trained on the equivalent of 45,000 years of gameplay. I mean, that's just wild. The system eventually gets a really high score, and there you have it. It looks like a genius. But what you really have is a system with incredibly high skill in one tiny area, but almost zero underlying intelligence. It didn't learn like a human. It just memorized a universe of patterns.
You've probably heard of this, right? It's called the AI effect. Every time an AI masters something complex like chess, people shout, well, that's not real intelligence. But it's not just about moving the goalposts. It's about this sudden realization that the AI isn't using flexible, general reasoning. It's using a brute force shortcut, a trick that a human brain just can't do. This right here gets to the absolute heart of the matter. When a human becomes a chess master, that skill is the result of their general intelligence. It's the proof that they have a powerful learning engine inside their head. The AI chess program, though, it's just a static artifact. The real intelligence wasn't in the program. It was in the brilliant researchers who designed it. The program itself is no more intelligent than a hammer is a carpenter.
So, if measuring skill is the wrong way to go about it, what's the right way? How should we be defining intelligence so that we're actually pushing toward creating AI that's more adaptable, more human-like? Okay, so a researcher named François Chollet came up with this really powerful new definition. He says intelligence isn't about how much skill you have, it's a measure of your skill acquisition efficiency. Let me say that again, skill acquisition efficiency. In other words, how good are you at turning experience into new skills across a whole bunch of different tasks? It's not about being good, it's about how quickly you get good.
This chart makes the whole idea super clear. Imagine you give System A and System B the exact same amount of training data, the same exact experience. System A kind of plods along and only manages to acquire, say, 20 points of skill. But System B, the more intelligent one, soaks up that same experience way more efficiently and shoots all the way up to 85 skill points. That difference, that gap in the learning rate, that's intelligence.
Now here's the thing. To learn that efficiently, a system can't just start from scratch. You can't be a total blank slate. You need an intelligence starter kit.
For hundreds of years, we've had this idea that the mind is a tabula rasa, a blank slate. But you know what? Modern psychology shows that's just plain wrong. Human babies are not blank canvases. They are born with a really powerful set of built-in assumptions or priors about how the world basically works. And these priors are the very foundation of our amazing ability to learn.
This is our starter kit. It's sometimes called core knowledge. We're born understanding that objects don't just vanish into thin air when we can't see them. We have an intuitive feel for agents, that some things, like people or animals, move with a purpose. We have a built-in number sense and an intuitive grasp of space and distance. This stuff isn't learned. It's the operating system we're born with that lets us learn everything else so darn fast.
Okay, so with this new definition of intelligence is learning efficiency, and with this understanding of these cognitive starter kits, how do we build a better test? How do we measure what actually matters?
The goal becomes totally clear. We have to stop creating benchmarks that just measure the final score. We need tests that evaluate the ability to learn itself. We have to measure the process, not just the end product.
So a fair test of true intelligence would have to follow some ground rules, kind of like these. It would have to use completely new problems that no one has seen before to stop people from just teaching to the test. It should be built on those same minimal core knowledge ideas that we all have. And it has to avoid any culturally specific stuff, like language. This is basically the blueprint for a new kind of AI benchmark that you can't just game with more and more data.
So the whole thing boils down to this. We need to make a fundamental shift in the questions we ask about AI. We have to get past just asking, what can the system do? The much more important and way more revealing question is, how efficiently did it learn how to do that?
This whole new perspective is your tool for cutting through all the hype. So the next time you see some big headline about an AI doing something incredible, you'll know the real question to ask. It's not just about what it did. It's about whether it showed true, flexible, efficient learning. So just ask yourself, but can it learn?